Yeah, good evening. Please go ahead.
Sir, our chief guests have joined, sir. Dr. Krishna Prabhu from IIT Tirupati, sir.
Okay,
Krishna
but
Prabhu,
your voice is not clear, Girish.
sir, hello, sir. Is it audible now, sir?
Audible, but it is not clear.
Okay.
Are you not using headphones and mic?
Sir, I'm using headphones, sir.
Okay.
Sir, Krishna Prabhu, sir. Good evening, sir. Hello.
Good evening. Yes. Can you hear me?
Welcome. Yes,
Better?
sir. Yes, sir. Clear,
Yes.
sir. Yes, sir.
Yeah.
Good evening, sir. Sir, actually, we are waiting for the Dr. Ramesh was from US, sir. So can
Okay.
we start in a couple of minutes, sir?
Sure. Yeah. No problem. We can wait.
Sir, our speaker also joined, sir. Sir, Ramesh, sir. Hi, sir. Hello, sir. Good morning to you, sir.
Good morning. How are you doing?
Yes, sir. Fine, sir. Sir, yes, sir. So our chief guest, Dr. Krishnavapurna, sir, is also there in the session, sir. Sir, Krishnavapurna, sir.
Yep. Hey.
Yeah. Yes,
How
sir.
are you? Hey, Ramesh. How are you?
Good. How are you doing?
Not bad.
Good to see you.
Good to see you again after TRB.
Yeah. So
Yeah.
in this virtual format, it's easy
Yeah.
to connect, I guess.
That's true. So you're in your office right now?
I'm here. Yeah, I thought the
Yep.
internet connection will be most stable here. So
Stable. Yeah.
I'm
So
teaching later.
how is Imad?
Oh, he's doing well. Yeah, he's doing
Yeah.
well. Busy as always. Very busy.
Yeah. It's good.
Good. How's everything there?
Going okay so far.
Good.
Yes, sir. Sir, can we proceed now, sir? Yes. So we'll start proceedings of this program inaugural. And then
Okay.
we can hand out the session at 6 p.m. Right, sir?
Sure.
Yes, sir. Thank you. Thank you once again. Yeah. The coordinators can proceed the proceedings.
Yes, sir. The ultimate measure of a man is not where he stands in moments of comfort and convenience, but where he stands in times of challenge and controversy.
A very good to Galaxy lectures, invited guests, professors, students, ladies and gentlemen. I, Sri Krishna, second civil.
I, Pujita of Second Civil, take this as a privilege to warmly welcome you all on the first day of 1 week International Student and Faculty Development Program on role of Transportation Engineers towards Sustainable Roads and Traffic Safety, organized by Department of Civil Engineering, Sri Vishnu Engineering College for Women, Bhimavaram, in collaboration with Indian Concrete Institute Student Chapter.
A day without prayer is a day without blessing. A little and a life without prayer is a life without power. So let's begin the occasion with a prayer.
Now, I request Miss Akila of Second Civil to grace the occasion with prayer song.
महागणपतिं मनसा स्मरामि महागणपतिं मनसा स्मरामि महागणपतिं मनसा स्मरामि महागणपतिम् वसिष्ठवामदेवादिवन्दितमहागणपतिं मनसा स्मरामि महागणपतिम् महादेवसुतं गुरुगुहनुतं महादेवसुतं गुरुगुहनुतं मारकोटि प्रकाशं शान्तं मारकोटि प्रकाशं शान्तं महाकाव्यनाटकादिप्रियम् महाकाव्यनाटकादिप्रियं मूषिकवाहनमोदकप्रियं महाकाव्यनाटकादिप्रियं मूषिकवाहनमोदकप्रियं महागणपतिं मनसा स्मरामि महागणपतिम्.
Thank you, Akila. That's an auspicious start. I am excited and feel blessed about this role as the 1 week international student and faculty development program is built with the intent of active and interactive learning.
Sri Vishnu Engineering College for Women was built during the academic year 2001 to 2002 to empower women in professional courses. This institute has witnessed significant growth within 15 years and stands out as one of the best engineering colleges in AP. This institute is accredited by NAC with A grade. This institute is under autonomous status from academic year 2014 to 2015, and it is the first women's college under JNK to get such an autonomous status. In recognition of this progressive strides, the World Bank has granted TUQIP Phase 2 project to SVCW. Indian Merchant Chamber recognized the service of SVCW with its Ramakrishna Bajaj National Quality Award in the education sector.
The Department of Civil Engineering SPECW was established in the academic year 2009 to 2010 with an annual intake 60. The department is accredited by NBA under Tier 2. The Department of Civil Engineering received the project from the Department of Science and Technology, New Delhi, worth of rupees 60 lakhs for the construction of 3 North sewage treatment plants in SPECW campus to treat the wastewater. The treated wastewater is utilized for various purposes and also serves Bhimavaram town. The department has good strength of specialized persons from structural, geotechnical, water resources, transportation, and geoinformatics. The department periodically organizes seminars, symposia, FDPS workshops, guest lectures for benefit of both students and faculty. SVCW has organized a total of 18 activities under ICI from the date of formation of this student chapter. It has conducted multiple webinars, conferences, mixed proportionating programs, with the noteworthy speakers from reputed organizations. SPCW has organized competitions for students under various heads like Motor Master, Crossword Puzzles, CAD Master, etc. under the guidance of HOD. The department was awarded with the Outstanding Student Year of Andhra Pradesh 2020. The department has an excellent blend of young and zestful HOD with well-experienced and elegant faculty.
The 1 week international student and faculty development program anchors over transportation as a sustainable concept and deals with the enlightening of present and future generations over the demand and call for innovative researches and experimentations in the field of transportation engineering for a better and sustainable society. Contemplating the initiative of a month-long complaint National Road Safety Month observed from 8th January 2021 to 17th February 2021. Let us join in necessitating safety as a prime move and promote the theme of this year.
Now, I heartily welcome Dr. G. Srinivas Rao, the principal of Sri Vishnu Engineering College for Women. He earned his PhD in Mechanical Engineering from Viscoelasticity Technological University, Belgaum, Karnataka. He has over 26 years of teaching experience. As a researcher, he published technical papers in national and international journals. He guided MTech students in the area of CAD, CAM, and more than 60 students in UG level. He is a life member of ISTE and CSI. He is also a member of SAE. He came the certified examiner for quality management of Indian Merchants Chamber Quality Award. I request Dr. G. Srinivas Rao, sir, to address the gathering.
Yeah, actually, sir has disconnected because of some technical problem. Then sir will start. Will join shortly.
Yeah, is it clear now?
Yes, sir. Yes, sir. Yes, sir. Please, sir.
Okay, sorry. Okay, so because it is not taken, respected Krishna Prapurnagar, Riyaj, and Girish, and my dear students and faculty of Civil Engineering Department, and the members of the other colleges who are joined this particular program. On behalf of Sri Vishnu Engineering College for Women, and especially on behalf of Civil Engineering Department, I am welcoming all you people for this wonderful program. Actually, I think 20 days back, our students and as well as the HOD came and took permission regarding this particular program. And I thought of looking into this particular program, but somehow I could not able to do. And today morning, when Girish told me about this particular program, so generally, whenever we are going to some particular program, we will Google what are the keywords which are there in the title. So I thought of putting a sustainable road, and after that I have read the safety. Then I removed the sustainable road, and about the safety, just I have Googled. And some of the what I can say disturbing facts regarding the safety of the roads is really pained me a lot. Okay, in 2019, okay, if you can see the statistics in India, nearly 1,51,000 deaths have happened because of the road accidents. Okay, and each year, nearly some 3 to 5% of GDP we are investing in the road accidents. Okay, so different aspects in that. Okay, so keeping all these things and reading all those material, I thought the importance of the safety of the roads, okay, is very, very important. And as well as I want to listen some of the speakers who are abroad, and where actually in the 2019, the deaths will be simply 37,461 deaths in the US in 2019 compared to 1,51,000 deaths in India. Okay, so there is a lot of things we are supposed to learn from them and try to implement. Okay, so I'll try to see some of the things. At least our next generation has to know about the importance of this road designs and road safety and all those things. And at the same time, I want to know a little bit more about the sustainable roads also. That's why we want to attend these programs. And I'm sincerely and wishing the civil engineering department for choosing this wonderful topic, and as well as bringing all the people, okay, so to on single platform where they can exchange the knowledge between that. Okay, so whatever the support which is required, okay, we will definitely do that. Whatever the inputs you are taking from the experts, those things we actually try to implement some of the things in our campus, where we have nearly about 100 acres campus is there here, so we can able to some of the things we can experiment and try to do some practical things also. Okay, so I am wishing you best of luck and grand success for this particular program for civil engineering department, and especially to Girish Kumar. Okay, thank you for giving this wonderful opportunity to me. Thank you very much. Girish, you can carry on.
Yes, sir. Thank you. Thank you very much.
Thank you. Thank you, sir, for your words of wisdom. Next, I heartily welcome Dr. Paula Girish Kumar, who has obtained his PhD in Civil Engineering from National Institute of Technology, Tiruchirappalli in 2018, at very adolescent age. He has been delegated as the head of the Department of Civil Engineering at SVECW Autonomous. He is a prime mover and instigator of Royal Civil Colloquium, established in the year 2019, whose cardinal motto is to expose women students to the technical and industrial aspects of working areas. In addition to all these institutional flourishment, he had organized several workshops for faculty and students and has been consistently working on various virtual programs like String Webinar Series, Digital Buying 2K20, an online events platform, short-term training programs, AICTE sponsored programs. Besides all, he was honored with National Award from Government of Tamil Nadu for the best project during the year 2014, Best Paper Award received for the paper presented in International Conference NIT Tirchi, and also won the International Best Researcher Award of the year 2020 in the area of Terra Mechanics and Nanomaterials in Pavement from IDMAS Learning Center, Malaysia, and World Research Council. Now I request Dr. Paula Girish Kumar, convener and coordinator of this international program, to address the gathering.
Yes. Thank you very much, Sri Sai Krishna. So, am I audible to you? Yes. So, well, respected principal, sir.
Yes, sir.
Today's chief guest, Dr. Krishna Prapurna, sir, and the speaker of the day, Dr. Ramesh Hus from University of Illinois, and the colleague head of the departments and colleague faculty, and my dear ladies and gentlemen, a very warm welcome to you all to this 1 week international student and faculty development program on role of transportation engineers towards sustainable roads and traffic safety as a part of Road Safety Month 2021. I would like to add a few words. The road safety we used to conduct per week, a road safety week, which is used to happen every year in the month of January, from most probably from 11th January to 17th January, which mainly aims to get the awareness on how to drive safely in order to avoid accidents and reduce the injuries from the government. Fortunately, this year, the government have announced and declared the road safety for 1 month, which is a long campaign towards better roads and better streets in India to a safer side. We all know a few seconds before Dr. G. Srinivasarao Garu have mentioned the statistics for the past few years, for the recent past, if you take last 5 years, if you see the number of accidents taking place or the number of persons killed because of the road accidents or the number of people get injured because of the road accidents is like a sine curve. So year by year it is rise and it is drop and it is rise and it is drop. There is no constant, though we are aiming for a zero road accident thing, still we are having a lot of problems, maybe because of the road condition or the pavement condition or the responsible driving behavior or the environmental condition. There could be a lot of facts that because of that the road accidents might occur. So this program, exclusively the role of transportation engineers towards sustainable roads and traffic safety, aims to give a vast knowledge or the experience that the experts have through from the industry as well as from the higher institutes in India and abroad. So definitely all the participants will get definitely the benefit out of this program. And I once again thank Dr. G. Srinivasarao Garu for giving this opportunity to conduct this. And also I would like to humbly thank all the speakers who are accepted for being part of this program by giving their experience, by sharing their thoughts to the participants participating across the different cities. Also, I would like to special thank our speaker of the day, Ramesh Hus, for accepting the invitation, and also our chief guest, Dr. Krishna Prapurna sir, who is always behind me for all the activities, directly or indirectly. Sir, I am very much thankful to you, sir. Once again, we are meeting in this platform, this program, and I take this privilege to proceed with this program. Thank you, ma. Please go ahead.
Thank you, sir. Now, I heartily welcome Dr. Krishna Prapurna, who is an associate professor in the Department of Civil and Environmental Engineering at the Indian Institute of Technology, Tirupati, India. He obtained both doctoral and Master of Science degrees in Civil and Environmental Engineering from Arizona State University, United States of America. During the last 15 plus years, he has been involved in several multi-million-dollar national and international studies that focused on fundamental material properties and sustainable innovative solutions or programs for adaptation and mitigation strategies to enhance quality life initiatives. He is a life member on Executive Fellow of the International Road Federation. He is also a recipient of Young Scientist Award from the Board of International Institute of Noise Control Engineering. In 2015 and 2018, he was awarded the Asphalt Rubber For the Republic of Indian instituted by the Rubber Pavements Association and Asphalt Rubber International Conference Group. He has authored, co-authored, and contributed over 170 papers in scholastic journals and peer-reviewed international conferences, and over 50 reports, press articles, newsletters, and guides till date. Now I request Dr. Krishna Prapunagaru to address the gathering.
Yeah, thank you very much. That was long. Well, thanks, Girish, for one more time, giving me opportunity one more time. This is the third time I think we are meeting since last year, July. That's really wonderful. It's heartening to note that you're doing this. It's an important aspect. And I thought I should tell this because this is a forum where we should probably do three things. Okay. Number one, what we are doing is to have capacity building measures. And that's something that we really require with so much of manpower that we have in India. Okay, so capacity building measures in terms of faculty development programs, or it could be some other symposia or international conferences. That will take us a long way to educate our group. Number two is to have collaboration. And I think that is something that we really have to do. It also gives us an opportunity to transfer the technology from not only the industry, also from the academia, right? It is required as a second step. The third thing is to have research put into practice. And that is where I think we really have to do much more than what we are doing right now. So if we are able to do all these three, I think we will succeed. And let's also encourage ourselves. So if you look at our own country, okay, we have the largest youth population in the world. It's approximately 650 million. And you can imagine it's double the population of the US. So Ramesh, where he comes from, they have about 300 million people, and we have double the population, which is youthful, right? And we need to be making use of this, and let's get encouraged. To all those who are participating, warm welcome, and we wish the best. And as I see the brochure, it's really diversified. We have asphalt paving solutions. Ramesh is there. And we have road materials, quality control. That's the other aspect, that really is required at this point of time to build excellent quality roads. The other aspects are on the traffic safety planning. And as Dr. Srinivasrao was rightly pointing out, it's something that we really have to take care if we have to get into the zero accidents. There are some countries who have also achieved, and we are really happy about that. Right, and we also have our colleagues talking about some sustainable solutions for pavements. And finally, that we really have to integrate this with the GIS platform. So I think it's a diversified group, and hopefully the entire audience will benefit from this. May it be from the student community or the research scholars or the faculty, young faculty, and those who are experienced. So wish you best from all quarters, and thank you again for inviting.
Thank you very much.
Thank you, sir. Thank you for your words of wisdom. Hereby, I hand over the session to Faculty Coordinator, Ms. V. Mansa, Madam.
Good evening, all. I'm Manasa Vatsavai, Assistant Professor in the Department of Civil Engineering at Sri Vishnu Engineering College for Women. I think I'm audible. Somebody please confirm.
Yes, madam, please proceed.
Okay, so thank you. Firstly, I feel very privileged to thank you all, to thank all the dignitaries who have attended this inaugural. Dr. G. Srinivasrao Garu, Principal of SVCW, Dr. B. Krishna Prapunagaru, Associate Professor, IIT Tirupati, and he's the Chief Guest of the program. Dr. G. P. Girish Kumar, Head of the Department, all the co-faculty members, and the members of other colleges who have attended this program, and all the students. Thank you all once again for being a part of our 1 week international student and faculty development program on role of transportation engineers towards sustainable roads and traffic safety, which was conducted in association with ICA. Now, without taking much time, I'd like to introduce the speaker of today's session, Dr. Ramesh M. Haz. He is an assistant professor in the Department of Civil and Environmental Engineering at the University of Illinois at Urbana-Champaign. Prior to joining UIUC, he completed his PhD and Master's in Civil Engineering at the University of Texas at Austin. He had obtained his bachelor's degree in Civil Engineering with a minor in Engineering Sciences and Mechanics from Virginia Tech. His current research lies at the intersection between materials, mechanics, and the pavement engineering. Primarily, his research focuses on asphalt binders, mixtures, and pavements. But more broadly, these research areas are situated in wider research areas of transportation engineering, viscoelasticity, composites, and computational modeling. So far, his work includes fundamental scientific discoveries into the origins of cracking in asphalt binder microstructure, as well as practical contributions to the asphalt industry, state departments of transportation, and local transportation agencies. To date, he has authored over 15 articles in a wide range of peer-reviewed journals in these areas and presented his work at many international conferences. Currently, his research had been funded by Illinois Department of Transportation and the Smart Transportation Infrastructure Initiative at the University of Illinois. With this brief introduction, I'd like to hand out this session to Dr. Ramesh Haz. So please take over. Sir?
Yes, hello,
Yes, sir.
sorry.
Yes, sir, you're audible, sir. Yes, sir, thank you.
Yes, sir.
Great.
Please take over, sir.
Great, thank you so much. And thank you so much for inviting me to
Thank you, sir.
speak. It's wonderful to be able to speak today. I'm gonna go ahead and share my screen. And let's see the presentation. I think it needs to be the other way. Okay, are you able to see my presentation?
Yes, sir, it is visible, sir.
Great, thank you. Should I start now?
Yes, sir, please go ahead. Thank you.
Okay, so thank you so much again for inviting me. It's really an honor to speak here today, and thank you to all of you for the kind introductions and the invitation, because this is such an important topic to discuss the transportation sustainability and to discuss the safety as well. You just heard a lot of statistics about the road safety, and I can assure you that it's not just a problem in India, it's a problem that we're facing all over the world. So no matter where you are in the world, road safety is an extremely critical problem. And as we work to solve it, it's going to take international efforts. So I commend you guys for putting on this symposium. This is really a wonderful topic, and I'm excited to share my knowledge, at least from the asphalt pavement side. So in this presentation, I'm going to focus on sustainability because sustainability and safety actually go hand in hand. And then at the end, I'm going to discuss going into the safety. And they go hand in hand because we have no choice but to pursue sustainable solutions now in the pavement engineering world. It's been now since the last 10 to 15 years especially, a lot of novel materials, a lot of novel ideas have come for how to make our pavements more sustainable. And now we are learning how to put them into practice, as Dr. Krishna mentioned. So we are now looking at how we can make our pavement infrastructure sustainable without compromising safety. So this is kind of the order that my presentation will follow in. I'll touch on a few studies that I've done, but I'll try to focus on the broader picture of why this is important. So the first thing I want to share is kind of how I see the field of pavement engineering. In the past, we always focused on predicting distresses, and predicting distresses is extremely important because this is what dictates the current safety condition of our road. So if we can predict our distresses in asphalt, these are majorly rutting and cracking, we'll have a good idea how long our road will be serviceable for. Of course, when I say serviceable, I mean the current condition of the road, right? So when we're thinking about a safety perspective, we're thinking about, is the road safe right now? And this can give us that answer. Now, in the future, what are our challenges? Well, we need to engineer better pavement materials. We cannot keep going with just the same old materials. We've already seen the introduction of polymers, introduction of other more advanced materials. And as we're doing this, our aim is a longer life, using more recycled materials, reducing CO2, and making our pavements smart. So now we want to take all of the things that we've done in the first part on the left, and we want to apply it kind of here on the right, to challenge ourselves to engineer those new 21st century materials that are sustainable. A lot of the problems in the asphalt world start with the binder. So what is asphalt binder? Well, it's the binding agent in flexible pavements, of course. It's obtained primarily from the fractional distillation of crude oil, but it also occurs naturally. You see some natural asphalts kind of in certain places, in Venezuela, in Hong Kong. There are certain parts of the world that have a lot of it, but generally for our purposes, we are focused more on this fractional distillation of crude oil. Essentially, this is the heaviest fractions of the crude oil or the bottom residue, and that's what will produce our binder. And in essence, we mix the binder with aggregates in approximately a ratio by weight of 5% to 95%. And the binder is extremely complex. So a binder, the interesting thing, I guess, I think if you studied more about concrete, and maybe many people here have a background in Portland cement concrete. If you study more in Portland cement concrete, Portland cement doesn't look too different if you're in the United States or in India or in Brazil or in Europe or anywhere. But asphalt binder looks quite different. It has a huge geographic variation, and this is because of its complex chemical composition. So I won't get into too many details, but the important thing to take away is that asphalt binder in general, every single binder is different. Which means every single mixture is different. No two are the same, even if that binder is sourced from the same source. Actually, different batches from the same source will still have differences. So it's very critical for us that we're thinking about the complexities associated with the chemical composition and how to properly know what type of binder we want to use. The other thing that makes asphalt binder extremely interesting to researchers is its thermoviscoelasticity. So this material behavior is not the same at all temperatures, and it also even depends on the loading rate. So if you load this material quickly, you will see it has a stiffer behavior, and if you load it slowly or have slow traffic, you will see it has a softer behavior. And this primarily dictates all of the things that I'll explore in this presentation. Of course, as I mentioned, each source having different properties, even from the same batch. And finally, when we see cracking in the pavement, like I showed on the previous slide, the asphalt binder is generally what's controlling the cracking. So it's extremely critical, and we cannot neglect the binder if we want to talk about safety or if we want to talk about sustainability of our road. We have to start with the binder, I believe. Just take a sip of coffee. Okay, it's very early in the morning here. So what are the new challenges in binder sustainability? Well, there's three I'd like to start off with, and then I'll talk a little bit about the safety as well. The first one is recycled asphalt. We have a chance right now with recycled asphalt to basically revolutionize the paving industry. So this is for the United States. I'm assuming there's even potential for more in India based on the huge population that Dr. Krishna mentioned. In the United States, we reclaim 90 million tons of asphalt each year, and we recycle approximately 80% of that. So about 75 million tons of asphalt is recycled. Based on this, we can have a cost savings of $30 to $80 per ton, which is pretty huge. But this is quite a large range and really depends on the material quality. More importantly, we can make a huge impact from a sustainability perspective. So when we reclaim the old pavement, we can prevent the need to produce more asphalt. And the more pavement, the reclaimed pavement we can use in the asphalt mixtures, the less we have to rely on distillation of crude oil, which of course is a process that leads to huge carbon emissions, very big carbon footprint, and is generally not a sustainable practice. So we like to reclaim asphalt. We hope that it's sustainable. And just to give you an idea how big this industry is in the United States, If you look at our total municipal solid waste, so this would be the things that people living in a city would use. So for example, disposable plastics, disposable aluminum, those kind of things. You will see that 67 million tons of those kind of everyday products are recycled, which means that asphalt, as I mentioned here, 80% of 90 million is recycled. So actually more asphalt is recycled than all these municipal products combined. So just to give you an idea of the scale, asphalt recycling is probably the biggest recycling industry in the United States. And asphalt can actually become the world's most recycled material. So this is not a small niche industry. This is a huge, huge operation that involves everyone. And if you can use more and more RAP and have a good performance of your pavement, you can see how this can go extremely far in producing sustainable roads. However, there's still a lot of challenges associated with using RAP. The major challenge is the compatibility between RAP and virgin asphalt. So the question is, when we heat the RAP material, we have to remember that this material is not like our virgin asphalt. This is a very stiff material. It's heavily oxidized, and it's difficult to mobilize and mix at normal temperatures. So for example, we use about 150 Celsius usually for mixing asphalt mixtures, if it's a regular virgin asphalt mixture. This might not be adequate for RAP because the material is so stiff and it has a high adhesion to the aggregate. So this may not be true, and this does create difficulty for us. The other challenge is certain RAP binders and virgin binders may not be as compatible as others. So we cannot just assume every RAP mix is the same. We have to assume there's some difference in compatibility, which means that we have to consider compatibility as we are moving through the process of a RAP mixture design. However, the vast majority of designs do not account for this. So the vast majority of designs just say, get 30% RAP or get 40% RAP and mix this into your asphalt. This is not going to work well because if it's not compatible with the virgin asphalt, the RAP essentially is just acting like a rock. And if it's too stiff, it's just acting like a rock, which means that you'll have an inadequate binder content, and these aggregates will strip or crack immediately. You'll have loose aggregate at the surface. Now we know, of course, when you have loose aggregate at the surface of an asphalt pavement, this creates a huge safety issue because that loose aggregate flies up and hits the next vehicle in the windshield and can crack the windshield of the next vehicle. So this is not something that we can take lightly, and it's something we need to explore. So this is something my research group has been working on. This was a collaboration with Dr. Anand Sriram and Zen Lang from Hong Kong Polytechnic Institute. And the other author is my PhD advisor, Dr. Amit Bhasin from UT Austin. This is a procedure that we developed quickly to check the extent of aging in RAP based on solubility. So the idea is that you titrate this with something that dissolves asphalt, this small specimen. And then when you when this solvent appears, basically when you see solubility, you understand that there is how much basically solvent it takes to dissolve this material, or how much dispersive force does this material have. So we can easily convert this to the amount of dispersive forces present. And if the material is not very dispersive, that means it might create recycling difficulties because the binder is too stiff and too brittle to be mobilized. So we kind of predict that this may lead to difficult binders to recycle. And we did some study of this. We looked at many different RAPs, and you can see kind of the D here represents dispersive forces. You can see that between virgin binder, of course, is ranked a 5 if you normalize it this way. And then you can see different RAPs, some have less than half as much capability to disperse. So this is a huge problem because, again, that means the material is very stiff and very difficult to work with. And you can see here that the RAP also varies quite a bit. So again, we cannot just assume, oh, this is RAP, so it's all the same. These are actual RAP specimens from the field. These are artificially aged in the lab, and we see that phenomenon regardless. So this is not just an effect of laboratory experiments. This actually occurs in the field as well. Now, We can also look at the interaction between wrap and base binder. And what we see also is that when we start mixing in 3 different concentrations, 15% wrap, 30% wrap, and 50% wrap, we start to again see that that dispersion changes rapidly. So 15% is largely okay, has very similar behavior to the virgin binder in the case of 2 different wraps. But as we start to add more and more, we start to see it become less dispersive. So again, this is a huge problem for us in the asphalt industry because we expect our wrap to behave the same way in all cases, but we know that if we're using a higher quantity, which of course is desirable from a sustainability perspective, we're going to compromise performance. So this is an issue that really needs fixing and needs more study. So these 2 papers that we've written kind of help to bring this issue to the front, hopefully for researchers in pavement sustainability, but we're just scratching the surface now, and there are more unanswered questions than there are answered questions. So I hope that in the future, researchers will focus on developing and understanding how we can create sustainable pavements, but from a scientific perspective, not just from the perspective that we've been doing where we treat every material to be the same when we know it's not. Okay, take another sip of coffee. Okay, so our second challenge is going to be rejuvenation. So what do I mean when I say rejuvenating or softening the binder? Well, the problem we just talked about where wrap becomes heavily oxidized, there is some remedy for this. And what we can do is we can use softeners. In these softeners, we have many materials. We have rejuvenators. Rejuvenators are often proprietary. These are kind of on the more expensive side. These are the materials that is basically some kind of liquid rejuvenator, low viscosity liquid that we add to the wrap binder to increase the viscosity, or to decrease the viscosity, sorry, and to make it flow more easily. But these are pretty expensive and these are patented materials, so we can't just go use them whenever we want. So there's been a lot of interest in kind of new softeners or rejuvenators, such as biomaterials. So biomaterials, some of this is animal waste. Some of this also includes, for example, cooking oils. So if we are using oil for cooking, we can recycle that in this form. I have done some work in this area also, and that kind of falls under here as well. And then there's high maltine oils, which are just lighter fractions of the crude oil. It's not ideal to use these because it's, again, contributing to the crude oil distillation, which we want to reduce. But in some cases, this can be a powerful tool for rejuvenating our binder. And again, the idea behind no matter which rejuvenator here you're choosing, the idea is the same. The idea is you add a low viscosity material to the very high viscosity, stiff, brittle wrap, and this will combine with the wrap to make it softer. Now, the question is, are these things chemically interacting? In short answer, mostly no. But in some cases, you may see some chemical interaction as well that could actually reverse aging. But in general, this is just blending something high viscosity with something low viscosity and creating a more workable material for paving. This can also help reduce the paving temperature, which can help reduce emissions during a pavement operation. So it's a huge win for sustainability if it's working. But the big question for these materials is, what content should we use? How much rejuvenator do we need? We noticed that this is co-authored with one of my PhD students and his master's advisor. And we noticed that in this case, there's a pretty wide range that you can use. So for example, here are 2 types of rejuvenators. JA is a industry, it's a industry rejuvenator, and JB is a waste cooking oil rejuvenator. And in both of these cases, you can use almost anywhere from 3% to 8.5%, 9%. And you can still maintain the same grade of your binder based on the PG system, which is the classification system we use in the US. So if you can still maintain your same binder grade in this wide range, what you end up noticing quickly is that you don't have a good idea of how much to use. Should you use 3%? Should you use 9% of the rejuvenator? So we developed a system based on the linear amplitude sweep binder testing method. And the idea here is that it's a fatigue test. So here we are actually checking what is the fatigue life of the binder from many different perspectives. So first thing we looked at is the damage evolution. And you can see here that the damage at failure of these binders is about 30% for an unaged asphalt. So A represents unaged, R is short-term age, RP is long-term age, and RP is doubly long-term age. So these are quite, this is increasing levels of aging. You will see that it takes less and less damage to fail the material. But then you can see as we rejuvenate it, it starts to go back up, right? And in some cases, actually, it even passes the original material, which is why I say that rejuvenation is a little bit of a misnomer. It's not necessarily the correct name for the mechanism, because in some cases, when we add so much rejuvenator, we are actually making the original material properties we're making the material properties even better than the original material properties. And what this means is that this is not a rejuvenation or restoring of the original properties, it's just a softening. And we can see that then when we re-age it, even we are able to keep some of those properties. And then finally, we can re-age, we can do many cycles of rejuvenation and maintain almost the same properties as the original. So this is quite powerful because, as I mentioned, we can then know that we can recycle the material, let it live another life in the pavement, and then recycle it again with the help of rejuvenators. We looked at fatigue life too. For example, same phenomenon here. As we rejuvenate, we see better than the original fatigue life. So even in the unaged original binder, we are actually able to restore better properties with rejuvenation. And this is at a lower level of strain, and this is at a higher level of strain. Crack growth rate, same thing. So here's our original binder. Here's our rejuvenated with 8%. So the more rejuvenator we use, the better performance we see. And then finally, we created a parameter to help us, based on all those characteristics, determine the most efficient rejuvenation rate based on the number of cycles to failure in a fatigue test of all these different strain levels, based on the crack growth rate and based on the damage properties. And this method allows us to very efficiently choose a rejuvenator content based on how much we want to rejuvenate the binder. So if we want to restore the original properties, for rejuvenator A, we use 5.1%. This is the aromatic extract. For rejuvenator B, which is the waste cooking oil, we'll use 8.3%. And we have a very targeted choice here. So this helps take the guesswork out of what I discussed before, where we use 3 to 9%. If we only want to restore 75% of the original properties, we can use as little as 2.7% or 3.6% rejuvenator. So this is, again, quite a powerful tool for us in asphalt paving, because this gives us a lot of options to restore those original properties. And this is really going to be the key to unlocking the use of high amounts of RAP. Right, as I mentioned, we could use 15% RAP without much consequence in the mix, but if we want to use 30%, 45%, 60%, we're really going to have to do something more advanced. And this is one way in which we can do it. So this is kind of work that we are super excited about, and we think can make a big difference to the asphalt industry. Finally, the last category I want to talk about is new asphalt replacement materials. And so when I say new asphalt replacement materials, what am I talking about? I'm talking about materials that we can use as total replacement for asphalt. The idea is that we eventually want to have mixes that are at least 50% of the material is not being used from virgin asphalt sources. One option is RAP, but as we mentioned, we're already using a lot of RAP. And RAP is still an asphalt mix. It still has a lot of the same drawbacks. So we are investigating new materials. One of the most common ones you might have seen come into play recently is, of course, the use of recycled waste plastics. So recycled waste plastics in asphalt materials is a huge, huge new popular area that is caught on a lot. And this is an area that if we can find a way to do it efficiently, this can really change the world of asphalt paving. So when we use, for example, recycled waste plastics, we need to make sure that it's compatible. If we want to use it, for example, 50% of the mix, we have to make sure it's compatible with asphalt. And this is no easy task. So we have all these plastic wastes right now. We have plastic spoons, forks, we have plastic dishes, all sorts of things that we want to recycle. And all of those are a little bit different. So we have to figure out an appropriate way to recycle these without compromising performance or safety of the asphalt mix. But today I didn't want to talk about plastics too much because I think this has been talked about. I wanted to talk about another project we worked on that had to do with sulfur. So in the 1970s and 80s, there was kind of a crude oil shortage, and the interest really arose to use sulfur extended asphalt. The idea is you could replace high amounts of your asphalt binder with sulfur. And what I like about sulfur is this is one of very few technologies that are truly scalable for pavements, especially because some countries, for example, especially in the Middle East and the Gulf regions, they have huge deposits of sulfur. So this is one option that could be extremely useful in the future. Previous studies did focus on sulfur as a replacement, but, and this is from the worker safety perspective, we have to take into consideration the health concerns with sulfur, which means that, we're typically using 150 Celsius for mixing asphalt. We cannot use 150 Celsius if we're mixing sulfur into asphalt because it emits too many hazardous chemicals. So if we want to emit raw elementals, if we want to mix raw elemental sulfur into asphalt mixtures, we have to use a lower mixing and compaction temperature. So in this study, we applied a mixing and compaction temperature of 140 Celsius, just tried to bring it down 10 degrees first. We noticed this decreases a lot, the amount of hazardous chemicals reduced or hazardous emissions. But we needed, of course, to check if the performance is as good. Because one issue with sustainability is that the performance will never, if the performance is not as good, the technology is not sustainable because you have to do reconstruction or rehabilitation so quickly. So if you don't have a good performance, you can forget about using that as a replacement technology. It needs to be at least as good as the asphalt mixture. So in this case, we evaluated sulfur extended asphalt mixtures using two tests. This is the Hamburg wheel tracking test and the Illinois flexibility index test, which is also known as the IFIT. So the Hamburg wheel test is a typical rutting test. And this test is used basically to apply these big steel wheels to the top of the asphalt mixture. And we check how much permanent deformation occurs in the wheel path. And this is analogous to rutting. Of course, rutting is one of the most unsafe asphalt pavement distresses. And that's because in pavement that ruts, basically you will have a depression in the wheel path. And when it rains, these depressions will fill with water and the vehicle will not be able to stop because there's water in between the tire and the pavement. So this is going to create a huge problem for us if we are not careful. So we definitely want to make sure the rutting performance is just as good. And then we have, of course, the cracking performance. And the cracking leads to infiltration of water into the structure and destruction of the pavement structure. So if we have either rutting or cracking, we're going to have huge structural issues, which lead to huge safety issues. So these are very important and very critical tests to run on any replacement material. And like I said, if your replacement material is not performing as well as your original asphalt mix, your technology is not sustainable and it's not safe. So we have to check these things before incorporating any such technology. Rutting, actually, what we found generally improved with the addition of sulfur. So the most permanent deformation was observed with 0% sulfur. Then as we increased 15, 30, and 45, we saw a continuous decrease, although these are all statistically very similar. We did see quite a good impact of the addition of sulfur. So we felt good about using this from a rutting perspective. However, what about a cracking perspective? Well, we saw more mixed performance, to be honest. So in 0%, we did see the highest fracture energy, which means it takes the most energy to fracture the mix. So we did see that the non-sulfur mix is performing a little better, but the peak load of the 30% sulfur was the highest. And this is important because the fracture energy is how much energy it takes to fracture the mix, meaning how much it can deform and strength combined. The maximum load is just the pure strength of the mix. So we did find better strength, but a little bit worse fracture energy when we use 30%. So in this case, we suggest to explore it more and that this could be a viable alternative, but we need to be very careful with cracking performance. And frankly, there needs to be a lot more study toward how we can reduce that mixing temperature and compaction temperature even further and maintain a similar performance. And the reason, again, is because of worker safety. We cannot compromise the worker safety. Which leads me finally to my last topic, safety in pavement engineering. So a lot of people think of safety as an operations problem. So they think of the people doing transportation operations, the people managing intersections and signal timings and things like that. But actually the safety is also a huge problem for pavement engineers. And you cannot get involved in pavement engineering without talking about safety. In this case, we're talking about restoring the surface friction. So the question is, why is the surface friction important? The surface friction is extremely important because basically this dictates the interaction between the tire and the pavement surface. So if there is zero friction, the tire will just keep sliding even when you apply the brakes. And this is, of course, not good from a safety perspective. Now, if there's too much friction, you will have to apply a huge acceleration to accelerate. And the problem there, of course, is you are using a lot more fuel to do that. So this is not really sustainable either if you have too much friction to overcome. So we need to balance this. We need to balance safety with sustainability. And this is one situation where they're a little bit out of sync with each other. So we need to be very careful when we say we're trying to do safe pavement engineering, because we want to restore the surface friction, again, without compromising sustainability and without compromising the performance of the pavement. We also don't want the ride to be very rough. So many have seen, for example, concrete pavements are generally a little bit rougher, a little bit more noise. That's one of the big advantages of using asphalt. So if we're going to use asphalt paving, we have to be thinking about reduction in noise and reduction in friction enough to be sustainable, but we cannot reduce it too much because it has to be safe. And the only way that a pavement can be safe is with a good surface friction and a good interaction between tire and pavement. So we did one project here where we looked, this was at UT Austin as a grad student, we looked at safety and pavement engineering from a surface friction perspective. So we applied cycles of loading of what we call a three-wheel polisher, which is basically 3 pneumatic tires applied to a pavement surface or a surface of a lab specimen of asphalt mix. And the idea here was to create some ultra thin overlays. And the reason is, as a pavement life progresses, you will see that the friction basically gets worse and worse because tires tend to polish the existing aggregates. So the surface friction interaction between tire and pavement gets worse and worse as time progresses. So what you will notice is a huge problem in terms of skid resistance or friction resistance in later ages. So typically what we do is we apply surface treatments. One such surface treatment is a seal coat. This is a single-sized aggregate adhered to the surface of the pavement with a binder. And this creates a nice friction surface, a good texture to restore that interaction between tire and pavement so that vehicles can stop in an appropriate manner. However, this procedure is a little bit complicated, especially in the US, because the technology to use it had a patent on it. So we were wondering, could we use just a ½ inch of a simple asphalt mixture of different types, and could we get the same surface friction? What we realize here is actually, in 2 cases at least, no. In 2 cases, we could not. However, in 4 cases, 4 types of mixes, we could get pretty good friction, including 3 that were actually better friction, even after 100,000 cycles of loading, than a normal range for seal coats. So we did recommend that this is one great option for agencies to implement, is to use this ultra thin overlay, which is just a ½ inch of asphalt mix. So it's not too expensive, not too much contributing to sustainability issues, but it is quite a good option in the case, as I mentioned, that you need to replace seal coats and restore that surface friction properties. Again, you can see coefficient of friction higher than 0.55 is pretty good from an asphalt sustainability. Usually above 0.55 is, or from an asphalt safety perspective, is quite good. Now, what needs more study? So I think that's kind of the last question here. And I would say what needs more study here is we have to understand what is the demand for surface friction in a pavement. What is going to make us want to, what is going to make us say, yeah, this is a good pavement, this is a good surface friction. So in that case, I think that there is a lot of questions still, and we haven't really answered this question well. So I hope that many of you will go on to study this topic, because I think this is an extremely important topic and one where traffic operations engineers can collaborate with the pavement engineers. Because the pavement engineers, we know, as I showed here, how to get a good surface. But the question is, when and where do we need to do these treatments? When and where do we need to restore that surface? And I really hope that the operations engineers can help us to answer these questions. So I think this is going to be a big challenge for the future of civil engineering, is operations engineers feeding into telling us and working with us in a feedback loop to understand where and when we can apply these treatments to be most effective in reducing accidents. At the end of the day, that's our biggest goal in pavement engineering and in traffic engineering, is how to reduce the number of accidents and how to save lives. This will be the most important thing, that if I can finish my career and say, yes, I helped to contribute to the saving of lives by improving the pavement quality, therefore improving the road safety, I think this is the greatest accomplishment any of us can say we had as transportation engineers. So with that, I think I'm right at the 40-minute mark here. So I'm going to conclude my presentation, and I'd just like to thank the sponsors and collaborators in this work. The compatibility work was sponsored by the Hong Kong Research Grant Council. The Sulfur Extended Asphalt project was sponsored by the Kingdom of Saudi Arabia, and the Ultra Thin Overlays project was sponsored by Texas DOT. So we had a range of sponsors, and of course, the wonderful collaborators who helped me to do this work. My PhD advisor, Dr. Amit Basin from UT Austin, and then of course, great collaborators from Hong Kong and Saudi Arabia who have helped us to accomplish this work. And with that, I'm happy to take any and all questions and would look forward to a good discussion with all of you.
Great, sir. Great. It's a great presentation, and it's a great privilege to us for your presence. Yeah, it's open to queries. So the audience are requested to post their queries in the chat box. Sir, will you be able to see the chart?
Yes, I can see the chat.
Yeah, right. Okay, sir.
Yeah, so I look forward to seeing what questions people have.
Yes.
So don't be shy. You can feel free to ask me any question about pavement engineering, about asphalt, about civil engineering as a profession. I'm happy to take any questions, so please feel free. So while we were waiting, Dr. Girish, can I ask you, is this lecture going to be posted later on YouTube?
Yeah. I even equally I'm seeing in YouTube also. If any queries post in the YouTube, then I'll mail you, sir. But from my side, I have little query since I'm working on nanomaterials. So normally I'm working on nanomaterials. I've used nano silica and nano clay as a partial replacement of this thing in bitumen. So you have told about RAP. So will it be any significant difference? Because your country, if you take your country, it's very cold. How do you differentiate the temperature effect when you use these nanomaterials in pavement?
Yeah, this is a great question. So one thing we saw continuously with the nanomaterials, we saw that this improves the high temperature performance. So in very hot climates, this solution can be extremely helpful. I did do some work with the nanomaterials in the past, and I think one issue we saw that these materials, they generally do compromise the low temperature performance a little bit of the mix. I know there is some really great work going on in IIT BHU, where they did look at also these nanomaterials in the low temperature, and they found that these are sometimes really compromising the low temperature performance of the mix. So we have to be very careful to use these materials in our mixes. But I think it can be done. And the question is, how do we modify the material? So we did work with some colleagues from environmental engineering when I was at UT Austin, and they helped us to modify the surface of the nanomaterial to create a better dispersion link. And this is really something that can be extremely efficient in creating a better nanomaterial that is more compatible with the asphalt, and especially at low temperatures. And we did see when we surface modify it, we can get equal performance at the low temperature. Again, for the climates, for example, in South India, I think maybe it's not so much problem about the cold climate, right?
Yeah,
So,
it's absolutely hot.
yes, so in those kind of climates, I think these materials are one great option. But in the colder climates for us, or maybe in the mountainous areas in northern India, this will be a huge problem. So we have to be very careful about modifying the materials first. Great.
Someone asked about,
Yeah, no, so I see one question here about can the pavement material be reused or not? Yeah, so this is kind of, I think, a good question. This is, as I mentioned, something where it's not so simple as a yes or no question. Yes, it can, but you have to be very careful about how to do it. And you have to make sure that you're not compromising, again, the performance. So cracking is going to be a huge problem. But in terms of reusing the pavement material, yes, it can be reused, but we just have to make sure we're not compromising performance. And again, I think you guys are so lucky in the warm climates because when you reuse the pavement material, it actually helps a lot with the rutting performance. So you guys are so lucky and can really have a good use of this material. I see there are some questions about somebody sent me a question on here, opportunities for women civil students. I think this profession has been really a male, more male students have pursued this profession for a long time, but this is something that's changing very fast. And I can say now we see a huge number of female applicants. I don't think there's any specific area that is best suited for women. I think that actually we are seeing now it's almost equal numbers in our department incoming sometimes. So this is really a good sign, and I think that we are continuing to make the gap, gender gap, smaller. So I think there's a lot of opportunity, and I think the biggest thing is just to focus on the area that interests you, no matter what it is. So if you are someone who's finding a lot of interest in pavement materials, that's great. That's more in my area, but there are so many good areas to explore. Now I'm seeing so many questions. This is great. Should I just continue?
Yes, sir. Please go ahead, sir.
Okay, great. No, so I see one question about the software-based simulation type research. Yeah, this is a good question. There's a huge opportunity. A lot of people are working on modeling, especially finite element modeling is the biggest one in asphalt right now. But again, we have to be very careful that these models are well calibrated. So we should always check our models with experimental and field studies. This is the best opportunity for us. But I would say finite element, if you are looking to get into the asphalt specific modeling, this is kind of the best one. Is cold regions, the curing of pavement can be done? Okay, good question. For asphalt, definitely. Actually, just the compaction is a little bit of a challenge because we need to be sure that we are having the material workable for long enough to compact. But other than the compaction, everything is okay. But for concrete, I will defer probably to Dr. Krishna for this question because this is, I'm not the concrete expert. So, so I think he will have to answer that question for that one. The addition of sulfur, why only sulfur? So again, as I mentioned, for us, sulfur is such a scalable material because there is so much natural sulfur in the world. So we have to be very careful. Again, we want to use the best material regardless. So, we do need to be very careful that we're choosing the best material, but I think sulfur is one good option because we have to choose also a material that there exists enough of it in abundance to improve the, to be used on a wide scale. I mean, if we can improve just one road, it's not enough, right? We need something that we can implement nationwide, internationally. Yeah. What else? The significance of rheology. Good question. So in terms of the rheology, we have to, again, we are thinking about the properties of the binder. And the reason we use rheology is because the binder is not really a true solid material. It's somewhere between, solid and liquid. So to use this, to consider the binder rheology, is very important because this is the behavior in shear, right? And in shear, we can say that we can understand the properties of a material that's somewhere between solid and liquid. So this is the significance of rheology, or why we use that. Can you explain a bit regarding additives replacement in bitumen? Again, so as I mentioned, this is basically an area where we have two reasons for wanting to add things to the bitumen. One is to reduce the bitumen content, or how much bitumen we have to use. The second is, of course, we want to basically improve the performance. So if either of those can be accomplished, then this is why we want to use replacement material or that kind of thing. Can we differentiate the grade of bitumen just by vision? Good question. Not by the eye, in my experience. I cannot do this by the eye yet. Maybe one day I'll have this skill, but no, I think maybe by vision of a microscope, yes, but by vision of the eye, I don't think it's possible, at least not yet, but I hope so. This is great. It's great to see so many questions. Just responding to a couple of them. Yeah, what are the best plasticizers? Well, we're not really using plasticizers in flexible pavements. Again, this is more for concrete because actually the material is, as we mentioned, flexible already. So it's quite flexible. So we're not really using plasticizers too much. We are more interested in the elastomers, for example, to make the behavior more elastic, because we want to reduce the permanent deformation of the material. Because as I mentioned, if it permanently deforms, then in the wheel path, you'll have some water building up and you will have a huge problem of the vehicle not being able to stop in appropriate time, which can lead to accidents. So, we want to be using elastomers so that those pavement materials will just restore their original shape and not deform. So that's kind of the most common one. What else? Which material is best for pavement on heavy traffic? Okay, so for heavy traffic, we should think very stiff, right? So as I mentioned, actually the wrap, for example, is a great option for if you have very heavy traffic and if you have slow rates of loading and if you have a warm climate. The wrap is really a great option. Now, of course, again, as you get into cold temperatures, the heavy traffic then causes cracks. So then we need to be much more choosy about what types of materials we want. But I think for the warm climates, the most stiff material is going to be the best for heavy traffic, no matter what. So you're going to want to use just more and more stiff materials to prevent deformation of the pavement surface. And this will be extremely helpful. Okay, did I answer every question? I think so far. Sorry, I feel like I just talked a lot now.
Yeah.
So, yeah, happy to answer any other questions that people have.
Yeah, we have few more minutes. So still we have few more minutes.
Okay, sure. So I was moving fast. So if there's anything people want to go deeper into, that's fine. So no, I really appreciate, again, the opportunity to speak. I think this topic is just so important, the sustainability and safety. So I think there's probably no more critical topic in pavement engineering today. Just respond also. So I hope it was informative, and I hope people feel that they learned a lot. But I hope this was a good program.
This was a good informative session, sir. And most importantly, we could see a lot of faculty and scholars definitely will help them to work in this direction, opting for RAP and try to see a lot of scope using RAP in our temperature conditions in India, in South India.
Exactly. Yeah. And I think this has the potential also, I think Dr. Krishna mentioned it in his opening remarks, about the progression to implementation, right? To really showing these results and working with our local governments and local agencies on how to implement these things. So I hope that, like I said, this will be one of the big takeaways, is how we can really put these things into practice now, take them from the lab to the field. I think this will be a huge win for us.
Yes. When you see nanotechnology, I'm not talking about nanomaterials, nanotechnology. We have a nano materials as well as nano rubber and rejuvenators, as you said, as you mentioned. So apart from all this, nanomaterials, nano silica, nano clay, or nano rubber, and rejuvenators, which would be the better option, opting to give a better
Good
performance?
question. Yeah, good question. I think, to me, it just really depends. I mean, I cannot say like one or the other for sure will be I think it depends on what you are aiming for, right? So I think with the nanotechnology, I think we need to be very careful, as I mentioned, because these materials, we need to make sure it's dispersing well in the asphalt, and we need to be sure that this, I guess the nano material and nanotechnology, a lot of the impact is at the interface between binder and aggregate. So we want to make sure that the bond is good, right? Because again, if you have a poor bond, like I mentioned, then you're going to have suddenly the removal of binder from aggregate, and you're going to have the loose aggregates, which again creates a huge safety hazard. So the other thing we want to check with this, I guess, that I didn't mention before, is the safety, for example, within the water runoff. So for example, that this water is going to become our drinking water, right? So we need to be very careful that the nanomaterial is not reaching the drinking water. So this is something where the environmental engineers will have to help us to solve this problem too, because this needs to be safe material. Now, when you say, yeah, in terms of rejuvenator, like I said, I think for the very warm climates, maybe this is not even necessary. Maybe you don't need to use a rejuvenator, because the rejuvenators, as I was showing, is kind of for the cracking performance. But the cracking is most critical in the lower temperatures. So maybe you don't have to use it. Maybe in some cases you still do if you have very heavy traffic, but I don't think it's always a requirement to use it. I think we have to be thinking about the time and place, and the reduction of the construction temperature is important to reduce the carbon footprint as well. So, yeah.
That's all, sir.
No,
I think, yeah. If at all any queries, if I receive, I'll definitely forward to you through mail, so you can address later.
Sure, and I would be happy. Anyone can send me an email as well, and you can always reach me by email, and I'd be happy to have more discussion with anyone. I think this has been a great discussion.
Yeah, one last small query, sir. So actually, about pavement management or maintenance. So we do frequently the pavement maintenance, right? So maybe if you compare the Indian roads with your roads, so we normally give a design life maybe 5 years or 10 years. So fortunately or unfortunately, every year we have a rainy season, or the temperature conditions vary. Ultimately, every year we see a lot of pavement distress, as you mentioned. So how do you do the pavement management? What kind of a pavement management system is there, and how do you differentiate? Like, which could be the better, optimal way of finding?
Yeah, good question. Good question. So I think our pavement management, we have the critical issue, I guess, in Illinois is kind of twofold. So we have huge amounts of potholes in the winter forming because of the freeze thaw. Again, not a problem you guys have to worry about, I don't think, about the freeze thaw. But we have a lot of times where the weather is cycling below 0 degrees Celsius. So in that case, we do a lot of what we call temporary maintenance, where we just fill the potholes for a short time, or we just seal a crack for a short time. But in terms of deciding to do the maintenance project, so in terms of doing a full overlay, as I mentioned, the seal coats and the other overlays, this is going to primarily come down to the current pavement condition. So in Illinois, we measure the pavement condition from a scale from 0 to 9. And usually around 4 or 5, then we start to consider maintenance if the budget is available. But this relies on continuous measurement of the pavement condition primarily. So we are measuring with laser profile, and this is how we are usually deciding about the maintenance.
Thank you very much, sir. So yeah, we are at the end of the session. Thank you very much, sir, for your acceptance. And though it is too early morning for you, so you take efforts to attend this workshop, and
no problem.
We are always happy to be part of any collaborative work in future.
Yes,
maybe
absolutely.
it is a kind of a student projects, or it is kind of again another platform in meeting, sharing your experience with the participants. So thank you once again for accepting our invitation towards this program as a part of this National Road Safety Month 2021 India. Thank you very much, sir. Yeah.
Thank you again to everybody for your attention and for having me.
It's a happy morning for you.
Thanks, and good evening for you.
Thank you very much, sir. All right, sir. I'll share the feedback to the participants. Yeah, you can carry on, sir. Thank you.
Thank you, sir. Thank you for sharing valuable information with us. So our first day on 1 week International Student and Development Program on role of transportation engineers towards sustainable roads and traffic safety has come to an end. We hope the same amount of participants for tomorrow's session that is going to be held at 10:30 a.m. I request everyone to join through the same link and make it as success as today. Thank you. Please fill the feedback form which is posted in the chat box. I request each and every participant to fill the feedback form.
Dear participants, please fill the feedback form which is provided in the chat box. So the morning session is at 10:30 a.m., sir.
We have 2 sessions tomorrow. Morning one slot and evening one slot.
Evening at 5 o'clock, sir. Morning at 10:30 a.m. We'll have one slot, and evening at 5 o'clock we'll have another webinar, sir.